All right. Thank you, Shalini. Good morning, everybody. As Shalini mentioned, today's webinar topic is on the evolution of software tools for CNV interpretation. I thought this would be an interesting topic, and with that, we're going to talk about our NxClinical software package. So let me start by talking about biodiscovery, in case the company is not familiar to you. We are not an instrument company. What that means is we do have close collaboration with all the instrumentation array companies, reagent companies. We want to make sure that our software is compatible with them. But at the same time, our focus has not been on creating a better array system or instrument, but it has been on creating high-quality software regardless of the technology that's used to generate that data. So this allows our customers to use the best tool at any point in time. By tool, I mean like arrays, reagents. So if it was back arrays at one point and then became step arrays and then going to NGS, you don't need to learn a new software or establish a new database, so you can carry over with that. Biodiscovery has been around since '97, so it's coming up to close to 20 years. And about half of that time, we have focused on also on the cytogenetics market. So going to the evolution of how we got to this point, I want to talk about the good old days. And if you recall, and maybe some of you still have it, an axon scanner used to get a two-color competitive hybridization for an ACGH back array. The extent of the software ended up being mostly an image analysis piece and then doing something relatively simple for visualizing the data. So this is the dye swaps of the backs. This is courtesy of a paper in leukemia from Combmetrics. So you can nicely see this event here, which I'm not sure if it's a gain or a loss at a particular band. So generating a report was relatively easy back then, but excuse me, as the array density and complexity increased over the past 10 years, need for software started to grow. So the first part was, well, there's too many probes to look at them visually, so there's an aberration detection or a calling algorithm that needed to be developed. And there's been many, like ADM1, ADM2, CBS, track segmentation, FAST2, PenCNV, you name it. There's a bunch of algorithms that have been created to call or detect the aberration or help in the process of detection. No algorithm is perfect, but these are all things that have been developed to help. In addition to software for the analysis, the visualization tools got more sophisticated. So added tracks for genes, visualization of genes, or other tracks like DGV from various vendors have their own packages. And back then, this is again about 9 years ago, Nexus copy number was also used to do both the calling as well as the visualization. And all of these provided hyperlinks to various web resources, NCBI, OMIM, and things like that to look up and grab information as part of the lab's workflow. Now, the vendors' softwares have evolved or changed. So cytogenomics is the new software that essentially replaced the Workbench. Affymetrix came up with the Chaz software. Illumina went through Courier Studio, and now with the BlueFuse Multi. Nexus copy number, in fact, hasn't changed for the past 9 years or so, and it just has evolved and has become more and more feature rich. So version 7.5 was released earlier, and now we're releasing 8.0 with NGS capabilities as well. So we've been fairly consistent with the Nexus copy number software. At the same time, the labs, in addition to having more complex arrays, they need to improve efficiency and turnaround time. And one important way to do that in the interpretation process has been to leveraging how previous cases have been interpreted. So if you've seen an aberration before, sorry, and how you have classified it, that could really help in improving the efficiency. So both within the lab and then from public repositories or other labs like ESCA project and the DGV. So how this was addressed has been through many labs use a very simple approach like the Microsoft Excel spreadsheet to keep track of their historical cases. Some labs even built in different degrees of complexity, their own little databases for previous cases. The users of Nexus Copy Number, in fact, use the Nexus Copy Number project for that, and which holds tens of thousands of samples. And other array software, array vendors like Bluefuse Multi has a basic database, CHATS 3.1, which is getting released, I think, right now. Just got added MySQL database for that, and OGT interpret software. But other commercial tools like Cartagena came out several years back, where it's a database, a multi-user database for storing these previous cases. There is no analysis component to it, but just housing the previous cases. So that was one solution to improving the efficiency, but more efficiency is needed because there are added demands. So the number of samples, the volumes is increasing, the diversity of tests is increasing. So in addition to postnatals, there's prenatals, various cancer cases, POCs, FFPE, panels, etc. So that is growing. And in addition to the growing volumes and types of tests, the labs have multiple personnel, like technicians and directors, doing different tasks. So how do you organize and make people work more efficiently together? And one of the most important part in a clinical lab workflow, as the technology is matured and it's moving away from being more of a research tool, a clinical lab requires consistency in reporting and processing across the entire enterprise. So that improves efficiency and quality, and that's a high demand. And as regulations are being more and more introduced, trackability, full audit trail, and access control has become more of a need as well. So what is out there as far as helping with these issues? Well, like I mentioned, things like Cartagena will help you with the pre-classification, associating phenotype to genotype with that part of it, but many other components here are not really answered at this current moment in time. So if you look at my cartoon illustration of the current state, you could imagine that data comes off the instrument, goes through an analysis software that could be vendor provided or through Nexus Copy Number, and some people might actually splurge and buy an interpretation software as well to help them with that, and then go through the LIMS and then finally generate the report. Of course, there are analysis software, including us and many other people, generates reports, interpretation software generates reports, and these things go back and forth, but I didn't want to add all sorts of complexities to something that's already complex. But if you think about the other dimension of complexity is the analysis software connects to previous cases. It also connects to various web sources, Excel spreadsheets. Interpretation software tries to do the same thing. And the user has multiple pieces of software that they are really needing to deal with, looking at various websites, and it makes the task rather difficult. In fact, as I mentioned, the growing number of people in the lab makes this even more complicated because there needs to be a need between various components or people in the environment. So why did we develop NxClinical? Frankly, we've had a very nice and growing number of clinical labs across the globe, reaching to over 100 labs that use Nexus Copy Number for generating or helping them in generating clinical reports. This is a very loyal and satisfied user base, and we keep getting requests to add more features. As I mentioned, we went up to 7.5 and now going to 8.0. The software has provided an excellent, responsive, and comprehensive analysis and visualization capabilities. It has a built-in database in the form of the project, as well as a cloud-based repository in NexusDB to be able to get previous cases. But frankly, it's a desktop software, and desktop application model have serious limitations for clinical lab needs, as I mentioned before. And in a very short summary, these limitations of desktop software, which includes Nexus copy number, CHAS, various other instrument-provided tools. One thing is it has not really been designed. It cannot support multi-user collaborative environment. You install the software on the desktop, and if you update the tracks on your computer to the latest version of OMEM, and your colleague in the same organization decides they're going to update later, they're out of sync. You're not using the same information or even the same version of the software. Yeah, if you make notes to some sample that you've reviewed, it's on your desktop. It's not really, you can't share it. You have to copy a bed file, for example, to someone else. So it's really limiting in a multi-user workflow. Even bigger issue is it's very hard to enforce because these are individual programs. It's very hard to ensure consistency across the enterprise as far as how samples are processed, how they're reviewed. That is a very big limitation of the software. And the other part is, as we're thinking about, and I think most of our users think about either transitioning or adding NGS technology, we want the users not to constantly change or have yet another software added to their pieces of software on their machine, is be able to have the same system easily transition to an NGS platform without losing the data. So because of all of that, we looked at this picture and decided, okay, we should get rid of everything here, the complexity, and just replace it with one piece of software called NxClinical that helps everybody across the enterprise and is able to take in and evolve with the new technology like the NGS technology. So talking about NxClinical and how it works is it's protocol-based processing. So what that means is there's something we call a sample type, and the user site, the administrator of the site, decides what sample types they want to use. And you can create sample types, let's say postnatal Illumina arrays. You can create a different one that's called postnatal Affymetrix. It doesn't really matter. What that does, you define how you want that workflow for these postnatal samples to be processed. So they have a set processing algorithm that is run. And the software also has a sophisticated variant interpretation assistant, which is a decision tree that you can put in the logic that your lab applies in marking the variants that are detected as whatever classifications you want to do, like pathogenic or benign or report, don't report, all of that. And that's based on for each sample type. So you can create one for postnatal, you can set up another pipeline for prenatal, another one for cancer, you can create panels, and all of these, in addition to the workflow customization that can be done, you can also customize the visualization and the tracks for that. So the beauty of the system at this point is all you need to do is load the samples and specify if it's what kind of a sample type it is, postnatal, prenatal, whatever, and everything else is automated. So it really helps in both inconsistency of the results and as well as the efficiency of the workflow. Talking about the VIA, or the Variant Interpretation Assistant, and this is courtesy of our customers at Affymetrix Molecular. Basically, you define how in your organization you interpret CNVs. So you could say, well, we first look if it's a duplication or a deletion. If it's a deletion, then we look at if it's a clinically significant region. If it is, Then we look at how similar that is. So this is one way that Combi, for example, decides to do that. But the language or the setup that we have here is quite comprehensive. You can have it based on the phenotype of the sample, to the different things, based on the regions of the chromosome, based on similarity to OMEM or PlinGen, etc. So you could create a very sophisticated interpretation algorithm that consistently generates the same pre-classification and brings attention to areas that need to be looked at quickly. So the last slide here just talks about the architecture. So as opposed to being just a desktop software that sits on your computer, that's the client. But really the heart of the system is the server that communicates with all these clients and provides them access to the entire database of all the samples and helps them leverage the knowledge gained from the reviews from each other. So that hopefully was not way too fast and covered the basics of what I want to cover here. Let me see if there are any questions before I move on. I don't see any questions about that, so let me then start and show you the software itself. So here's the NxClinical. You actually need to log into the system, so I'm going to log into it as the administrator. So in case I need to show you some of the admin functionalities, I can do that. Just to be clear, in the 20 minutes or 30 minutes that I have left here, it's probably not going to be enough time to show you everything, so I'm going to try to only point to certain highlighted areas. And feel free to ask any questions so I can come back and answer them and point to them. So here's the software. Once I log in, I get an interface much like Google because all the samples are now in the database. I can query the samples. I can search for the sample by a number. So I can say, okay, give me sample 17, and it brings it up. Or I can do more sophisticated queries. But I wanted to show you or start off by going through a typical workflow. So let's say I'm the user that is tasked to load data into the system. Now, in this way, you can have different people doing different things. So the user that's going to load data into the system comes in here and says, okay, I have now a bunch of samples, and there are what sample type. If you recall, I said you can configure, or the admin configures different sample types, and maybe I have an example here, which is a Illumina 850K constitutional case. So that's a sample type, and I click plus, I find where those samples are, so hopefully I didn't delete it. There it is, demo. And I click it. Now, of course, that person can load up 100 samples and do the same thing. You can also have the patient name, other types of things all loaded. But I just want to show a very quick demo. Then I can do a upload and process. You can see that sample just got uploaded from my client onto the server, and it's being processed on the server. So that could be the job of one person, just to upload that. We could even automate that process. If I wanted to find that on the server, I can just say, okay, pending, because it probably hasn't finished processing it. So what the server is doing now, and I just queried for anything that's pending to be processed, it says, okay, that sample, demo sample, is pending to be processed by the processing server. It already knows what kind of a sample type it is and what is the allowed processing type, with what settings this needs to be processed. So, so it's no longer shows up because it's no longer pending, so it's gone. Now, if I want to find it, I can look for it by typing the name, say, okay, demo. The usual workflow, though, is, as you can see, this sample is in state. So if I'm the technician that now needs to find all the samples that have been loaded and processed, I can just come here and on the workflow stages query for those samples that have not been reviewed. And if I do that and remove this one, you can see I have a lot of unreviewed samples, so I'm not going to do that. So let me just find the demo sample. And the other thing you can notice is that the automatic pre-classification rule has been applied to this. So the software has already, in addition to identifying the aberrations, has already detected that there is one potentially pathogenic event in this sample, and a couple of WUS variants of unknown significance, and a few benign cases. So if, and we can take a look at this in more detail. Before doing that, I wanted to show this sample info. So this is the information about this sample, and you can change the display name or add patient name. As I said before, all this can be brought in from an Excel file too. But and you can create link samples or family relationships and look at trios. But if you had some phenotype, so this is a postnatal case, and if you had some phenotype, you have access now to the entire HBO, Human Phenotype Ontology database. And let's say this sample had an intellectual disability, and let's say I also want to add speech delay to this. So I can add these phenotype data to this sample. And you can see later the software actually leverages this information in prioritizing what regions are potentially related to the phenotype. So if I click on the sample name, it will launch a new tab, as you can see up here, the demo sample here. And this is the single sample review screen. So what the software is doing right now is also customizing the view for the way that sample type was defined. So you can have one view for your postnatal cases, you can have different tracks and different table for your prenatals, you can have different ones for your cancer. So it tries to make life as easy as possible for the folks using the system to be able to run through many samples efficiently. As I mentioned earlier, the software had detected, and you can see here, there's a region about 6 megabases, and you can see it's at the tip of this chromosome 22. If I click on that, it brings that region up to focus. Let me extend this out. You can enlarge some of these things. So you can take a look and say, yeah, you know, this the technician could say, yep, this looks like a fairly real call. I don't see anything to be able to frequency supports that evidence. And this black mark over there says that it is pathogenic. That's the color of a sign. If I put my mouse on there, it's saying that it was called pathogenic because it matched almost identical, 0.98. Previous cases reported in ClinGen that as curated pathogenic events. So I actually do have that ClinGen postnatal pathogenic, and if I can move some of these things around and scoot down here, you could see, if I go down, you could see some of these with the actual phenotypes for those, and you can see there's a bunch of deletions in these areas. These are all hyperlinked as well, so if you really want to go to that ClinGen case for that one, you can get to it. But so that's how it had decided, based on the rules that I had set up, close the OM and morbid ones, that this is pathogenic. But let's say you also want to know what about in your own database. So if I put my mouse here on this little triangle, it's telling me that there are 7 cases in my database of previous cases that have a similar deletion in that region. So 7 out of 1,700. And if you wanted to see how you have previously classified that, just to make sure you're consistent, you open this up, and then you can see these are the previous cases. And this last one is off of an Agilent legacy 180K sample. It was much smaller, but that was also reported as being pathogenic. These other ones are Agilent arrays, but they weren't classified, the samples that I had imported. If you wanted to look at any of these, you could click on that, and it opens up a new tab. And you can see, oh, here it is. This is the sample, and it loads the. And now you can see that, well, this is actually might not be the case. That's similar because it is a small section of a much larger deletion event. So you have very quick access to your own internal database of samples, regardless of what type they are. In fact, if what I mentioned was it's finding similar cases. So if I go in here and say, well, don't worry if they're similar or not, just remove that filter by unchecking this. If I put my mouse over here, now it's saying there's 54 cases that have a loss in that region. So if you look, you can see there's all sorts of small and big and all sorts of crazy things. And they're sorted based on similarity. So the last things at the bottom are the least similar events. Or you can change the amount of similarity that you're looking for. And don't confuse similarity with overlap, because similarity is really similar cases, not just overlapping. So that's how you can see previous cases, and we have that here. This is, if you click on the region, you can see all the genes. This is something we had an NxCopy number, all the genes within that area. So that was the pathogenic case, and if I'm the reviewer, I click this edit button, and I can now add my notes in here. I can type in my notes that says, yes, it is a pathogenic call based on whatever, and I can close this, and that note is showing up in here, as well as if my colleague is looking at this case in a few minutes once I'm done, this is already available for them to see on their mouse over, so they can see what I have said. Now, if I can move this panel somewhere else, if I go to, for example, this VUS over here, this is another case. So this one shows up as being a variant of unknown significant, and if I put my mouse on it, it says that it's because it overlaps an omomorbid gene. So it wasn't clearly something that showed up, and if you look down here, it didn't show up in any of these ClinGen pathogenic or benign categories. If I expand it, these are much larger events, so it couldn't really tell if it's pathogenic or benign. So at this point, I can look to see if in my database I have any similar cases. It's like, well, this is another one. This one's in fact the same thing. It was reported as a VUS. But what I wanted to show was this other column, which is called the evidence score. What the evidence score does, it takes advantage of the phenotypes. If you've entered the phenotype information, it finds any genes within that region that are implicated in the reported phenotype. So we said intellectual disability, and now it's coming up that this NT5 C2 gene has been implicated in intellectual disability, and it's over here, and you can read more about it, you can look at the gene here. You can click on it and go to various sites if you wanted to. You can see if it has any different splice forms. So there's a lot of helpful visualization tools that you can do at that point. So the person whose job is maybe to look at these cases, they can go through, they can look at these and says, oh, this one's likely benign. Why is it likely benign? Because it doesn't overlap anything. It's in a gene desert area, and there are how many similar cases? Well, there are 7 similar cases. They've been reported the same way. So once that person, something else that the initial tech review usually does is also to look at the whole genome. So they can, many labs like to still look at all the probes to make sure there's no mosaic events or something like that. Maybe let's say this tech here decided, oh yeah, I see there is a seems to be, let's zoom into that area and say, oh, there's a mosaic gain or loss. So they can go, in fact, to that chromosome, let's say chromosome 5, and decide here that, you know what, I think there is, this region is a gain event. So they can add that manually. What happens is, right now it says it's unclassified and manually created by this this person, whoever was that logged in. And you see it took about, I don't know, a few seconds, and now there's that black line showed up, and the classification changed to automatically to pathogenic. And you can see now, if you go over it, why is it pathogenic? It's essentially because there's one of the rules that I've set is that anything bigger than 10 megabases, gain or loss, is marked as pathogenic, and this one is like 50 megabases. So, and in addition to that, automatically shows up with 5 similar cases in my database, and if I look at that, these are the similar cases to something that I completely made up. Now, you can go in here and you can add more notes saying, I think this is a mosaic gain. And as Tech 1, I could say, okay, I'm done with this, so I'm just Tech 1 review completed. I change the workflow stage and stop at that point. Now, let's say the director comes back and opens this case. Let's say I close this. See, it says Tech 1 review completed state. And if I go back in here, and the director comes in here and says, oh, let me take a look at what's going on. Or Tech 2 comes here and looks at this and says, oh, I think it is a mosaic gain. Let me look at that data, and I don't think that's the case. So the Tech 2 person goes into the edit mode and deletes this event. So now that's gone. It's no longer here. But you notice, because of the audit trail, then that's actually now shifted over to this deleted regions. And if you click on that, it highlights the region that was deleted. So if now the final reviewer comes back and says, no, I agree with this, they can even restore this back into here. So all of that is being tracked by the software. Again, this is a multi-user environment, so other people could be interacting with it. But hopefully, as you can see, it's very automated and protocol-driven, and allows you to quickly go through the case. And now to generate a report, we have many different ways that the user can generate reports from the system. I know many vendors put in, oh, you can put in your logo and nice report, and not many people really use that. So we decided not to go down that route directly. We have 3 different types of reports that you could generate from that. So one would be you can export this table, and you can customize this table in many different ways. You can add this, and you can add and remove and move things around, what you want to include in the table report. And then click this button and export this out as a tab delimited text file. So that's one way, and suck that into your LIMS to generate a report. There is also a report tab here where the contents of this table is shown in more of a report, and this can be cut and paste, and it's also hyperlinked. So if you click on this one, it takes you over to that area. It shows you how it was classified, and if you had like certain genes on it, the almond morbid genes in those regions will show up. These are also hyperlinked. So it's more of an interactive HTML type of report, but at the same time you can cut and paste anything from here. And finally, the third method of generating a report is clicking this button up here, and it will generate a PDF report that the admin can customize for each different sample type, saying what things to include or not to include within the report. And actually looks to me like I didn't customize this very well, so it's going to be a long report. But you can put in different figures like the overview if you want to include the log ratio plots, if you want to include all the processing settings, and then pictures of variants, events, and tracks. So this is all customizable as far as what tracks to put in, what if they only show pathogenic or show all events. And if I go to the bottom for each event, you can also customize what information to put in. We call this more of a technical report rather than something that you want to hand over to your clients. So this was the part that I want to cover as far as a quick end-to-end. The software also allows you to visualize trio samples, so you can look at the trios, the father, mother, and the affected child, or if it's cancer, you can have, cancer normal or metastasized, and at diagnosis, you could do that. And I'm going to stop this. I do want to allow more time for Q&A. So last thing I wanted to talk about is maybe how the general query works here. So the general query here lets you put in anything. So you can put in things like I'm looking for those samples that have a gain of orexin 1. And mistyped. And then these samples show up. I can limit that to a particular type, so I say, well, only in the AFI constitutionals do we have any, so then these two show up. You can also say, well, I want to find any sample that has certain phenotype. I can put in the phenotype of that sample. So it's a very easy way for you to identify cases for review. There are many things in here that I would like to talk about, but I think at this point I'd rather stop and answer some questions and then go from there. So let me see, because I noticed from here it's flashing that there's a couple of questions. So let me see what the questions are. And feel free to type in if you have any particular area you want me to show. So the first question is, do you update annotations and tracks? How is that handled? Thank you very much. That's a great question. One of the big things that we introduced, big features that we introduced in the latest version, Clinical 2.1, is the ability to automatically update the tracks and annotations. So it connects to the server and comes up. So I actually have updated most of my tracks except these guys, but the ones in red are, since I'm the admin, I can do this. The typical user will not be able to do this. And this is very important. This goes back into what I said earlier, that you don't want to have different people have different tracks at the same time. So if as admin I decide, okay, I want to update all the OMIM tracks, I click that and I update it, and then next time anybody logs into the system, their OMIM track is updated, so everybody has the same version. So we are curating all of the OMIM and ClinGen and cancer tracks that we monitor for updates and make them available as soon as they get updated, so the admin can set a policy that they want to update these every month, every week, every quarter, and that is done. The next question is, can different users access the same data at the same time? What happens if two people make changes? Okay, great. So because it's an enterprise system, if you have multiple people working with the system at the same time interacting with it, as you noticed before, there's no problem. People can look at the same sample at the same time, but two people cannot edit the sample. So if one person goes into edit mode on a sample, it tells other people they cannot edit it until that user is done. So this helps ensure consistency of the result. Next is, what is the database required? So the database that we have is a custom NoSQL database, which scales quite well. And the nice part about it is you can run it on, like I'm doing on my laptop, or it can be on a very large in-house server, or it can be put on a cloud. So it's a very flexible deployment. Another question here is, does it support the Illumina cytosnip 850 bead array? Absolutely. Actually, I think the one I was using as the demo was the 850 K array. As you can see, they're all over the place. So either generated through the BlueFuse data or directly through Illumina, where's that? So it's here, and I have some cancer samples. So if I want to query, these are 56 samples that are off the 850K array. But in addition to that, it supports pretty much any platform, Agilent, Affymetrix, Illumina, etc. All right, so I think that was good going through those questions. Feel free to add some more, but I do want to give Shalini a chance to put up the polls, a couple of quick polls.
Great, thank you very much, Dr. Shams.